Hello there, it's Lana, and I'm going to see if I can help you with 5.3, number 27. All right, as usual, I'm going to do the example. So it says among 50 to 55-year-olds, 35% say they have given a speech while under the influence of alcohol. Suppose 8 50 to 55-year-olds are selected at random. What is the probability that at least one of them has not given a speech while under the influence of alcohol? And letter B, what is the probability that at least one of them has given a speech while under the influence of alcohol? Okay, I've already done this problem and the computer ate my video, so let me just go back here. So what I did was I made a table for myself. And I said, okay, let's let X be the number of people that have given it with alcohol, just for the sake of it. So given a speech with alcohol. So here's nobody's given a speech with alcohol, so none of the 8. All right, and then one person has given a speech with alcohol out of the 8. 2 have given a speech with alcohol out of the 8, and so on, all the way up to all 8 of them have given a speech with alcohol or under the influence of alcohol. All right, now the trick is that the first probability and the last probability are actually pretty easy to find. It's all the ones in the middle that are a giant pain. So let's think all 8 of them. Well, if the chance of giving a speech under the influence of alcohol is 0.35 according to what they say, then you want 8 of them. You want the first one, the second one, the third one, and so on. So it's 0.35 to the 8 power, right? Because you want 0.35 times 0.35 times 0.35 8 times for the 8 people. All right, so that's all 8 of them have. And then up here is none of them have. None of these 8 people have ever given a speech while they're drunk, right? Or under the influence of alcohol. So that's 0.65. So that's the chance the first person was not under the influence. And then the next person is 0.65. And the next person's 0.65. And then you have 8 of them all together. Now, the real hard part is that all the ones in the middle, you actually don't know how to find at this point in 5.3. There is a formula for learning how to do these that you learn in section 6.2. But until that point, you could find them, hypothetically speaking, with what you know, but it's very tricky. For example, here's the chances that one of them, just one of them, was under the influence of alcohol. To which I ask you, which one? The first one, the second one, the third one, the fourth one, fifth one, sixth one, seventh one, eighth one? And the answer is yes. Yes, all of them, right? So you'd have to find the probability for each one of those options. Find the chances that the first one was drunk, the second one was not. All right, second, third, fourth, fifth, sixth, seventh, eighth, not. Then find the chances the second one was drunk, and none of the rest were. Then find the chances the third one was drunk, and none of the rest were, and so on. And that's actually the easiest one to figure. 7 works the same way. But 2 and 6 and 3 and 5, well, which 2? Do you want the first and the third, the fourth and the seventh, the second and the fifth? What? Right? And the answer is yes, all of them. So you'd have to figure out every possible combination. Hopefully you can see that that is very tricky. Now, luckily for you, there's a very simple formula to do it. It's called binomial. Binom dist is what you're actually going to use. I'll show it to you. It's equal binom dot dist. See that? There's a function for it, and we'll deal with that when we get to we'll deal with that when we get to the lovely section 6.2. But until that point, you're kind of stuck, right? There, if you really want to know the probability, there it is, right? But you wouldn't know how to do that until you get to that section in that chapter. Okay, so you're going to have to do this a different way. Now, the thing is that they're asking you, what's the probability that at least one person has given the speech under influence? Oh, and by the way, I'm doing this backwards. I'm doing part B first, and then I'll go back and do part A, and then we'll just enter both answers, okay? But I think at least one person has is a little bit easier to understand. So at least one person has. Okay, well, that's all of these. All of them, right? Every single time in here, somebody, either one person, 2 people, 3 people, so on, has given the speech under the influence of alcohol. But you don't know all these probabilities in here. You don't even know how to find them until chapter 6. So what could you do? And the answer is, well, you don't find all these green ones because you can't. What you can do is take this one up here, which I'll make blue, and I will take it away from 1. I'm going to find this guy, which I already did find, and subtract from 1, and I'll have all the rest. So I'm going to take 1 minus that 0.03186, and then I actually formatted, right-click, format the cells, and I said 4 decimal places. And there you go, right? So again, you don't know how to find all these. And no, it didn't ask you to find a table, but it doesn't mean that it's not a helpful hint. I actually do that a lot of the times when I'm working problems like these, I'll try to set up some list for myself and say, okay, I could have 0 people, 1 person, 2 person, 3 person, and then try to figure out what they're asking. All right, let's move actually to part A, which is a little bit backwards. So it's the same table as before. All the middle ones are tricky, yada, yada, yada. So they want the probability that at least one person has not given the speech under the influence, which is a little bit strange. If at least one person has not given the speech under the influence, that means there's at least somebody who, of these 8, because there's 8 people you're looking at least one of them, but maybe more, was not drunk, right? Okay, well, here are all the ways that can happen. I'll do it in yellow this time. Okay, so it could be all 8 of them were not drunk, or it could be 7 of them were not drunk, but 1 person was, or it could be 6 of them were not drunk, but 1 person was, right? And so on. All the way up to this one where 1 person was not drunk, but 7 of them were, right? 7 of them had alcohol or gave a speech under the influence of alcohol, 1 person did not. Okay, so the complement of that is this guy down at the bottom. I'll give him blue again. So instead of finding all these, which I actually don't even know how to find, I'm going to find the blue one and take it away from 1, which is exactly what I did. And then I just right-clicked and made it 4 digits. Right? So again, at least one person has not given the speech under the influence. That's 1 minus the probability that all of them have given under the influence. They're complements of each other. Right? Not under the influence, the complement is all of them under the influence. Over here, 1 person has given the influence, then the complement is none of them, right? So the complement of at least 1 is none. The complement of at least 1 not would be all of them, right? Or not, if you will. These are the people that have not been not under the influence, i.e. all of them are drunk. Okay? All right, I hope that helps with that one. It's a little bit tricky to think about. I honestly think it helps to kind of make a table like this, even on your paper, just by hand, and try to figure out, okay, they've given me enough to do the top, they've given me enough to do the bottom, but until chapter 6, you really don't know how to find most of the middles unless it's a very simple problem of like 2 or 3 coins. That's about it. But much more than that, you're going to be stuck. Okay? And again, think of it this way. This one, at least one person has. Notice that's a positive. See, at least one person has. So you find the complete negative. None of them have. This one's at least one person has not. That's a negative thing. So you go with the positive. All of them have, right? So this is all, right? So these ones are all the at least one not. That's negative, right? So you go for the opposite. And then this is none, and the complement of that is all the rest of these, which are at least 1 has positive, right? That's another way to think of it, kind of logically speaking. All right, I hope that helps.